Good day everyone. Today we're going to talk about our lesson 1, which is the greatest common factor and polynomials. This is the lesson for mathematics 8 for, of course, grade 8 students. So let us proceed. So in this lesson, you are expected to first find the greatest common factor of polynomials. Second, identify and differentiate among types of polynomials. And third, we have to identify the degree of polynomials and the number of terms. So looking at the pictures here, during the quarantine months, children were required to stay at home, and with that, parents need to go to the market to buy a variety of food, beverages, and household products. There are even similar products that you and your neighbors bought in the market. It can be because of common taste, demand, needs, or favorites of two or more people. So, looking at the picture above, can you identify the common items or products that you want to eat? In line with your observation, our lesson will focus on finding the common factors of two or more numbers or polynomials. So, in this lesson, you will learn the basic concepts of greatest common factor or GCF and polynomials. As you read, please take note in finding answers to the following questions. Number 1, how do we find the greatest common factor of a set of numbers or of polynomials? And number 2, how can polynomials be classified? So let us now proceed into discussing our lesson on the greatest common factor and polynomials. So when we define the greatest common factor, it says here that these are the highest number that divides exactly into two or more numbers. It's like this is the greatest thing for simplifying numbers or even fractions, of course. So the GCF of two or more counting numbers is the largest whole number divisor of the given numbers. So we can use different ways in finding the greatest common factor or GCF of a certain group of numbers. So we have here the factoring method. So you simply need to list all the factors of a certain from smallest to highest, then look at the highest common factors of the numbers. So for example, we have here, we need to find the factor of 12 and 24. So we simply need to list all the factors of 12. So we have here 1, 2, 3, 4, 6, and 12. Then for 24, we have 1, 2, 3, 4, 6, 8, 12, and 24. Then you need to look at the highest or greatest number that they have in common. Both of them have 1, have 2, have 4, have 6, and have 12. However, the highest number that they are in common is 12. That's why the GCF of 12 and 24 is 12. Now, we have the second way on how we can get the greatest common factor of a certain or group of numbers. So we have the factor tree method. For the factor tree method, this is one method for producing the prime factorization of a natural number is to use this one. Okay, so the first step actually in making a factor tree is for you to find a pair of factors whose product is the number that we are actually factoring. So these two factors are the first branching in the factor tree. Usually there are several different pairs of factors that we can choose to begin with. So the choice actually does not matter. Okay, so we can begin with any factor. We repeat the process with each factor until each branch of the tree ends in a prime. Then we can use the prime factorization in which it guarantees that the same number will result in the same unique prime Okay, so let's have an example. Once again, we need to find the factor of 12 and 24. So using the factor tree method or the prime factorization, think of two numbers that when you multiply, the product is 12. And that is 4 and 3. Actually, you can also use 6 and 2. But I choose to use 4 and 3. Now, between 4 and 3, is there a certain number that you can still factor out? Okay, that is 4. So we have 2 multiplied by 2. The answer is still 4. So the prime factors are, or factorization of 12 is that we have 2 times 2 times 3, which is equal to 12. Now, let's move with 24. Once again, think of two numbers that when you multiply, the product is 24. So I choose to use 8 and 3. So between 8 and 3, can we still factor out number? That is, we have 8. So we have 4 and 2. And once again, we can also factor out 4. So it became 2 and 2. So this time, the factors of 24 are, we have 2 times 2 times 3 times 2. So as you can observe, pinagpantay-pantay po sila, yung mga magkakamukhang factors. Okay? So, in that case, we can say now that 2 times 2 times 3 is equal to 12. Yun lang kasi yung magkakamukha sa kanila. So, in that case, we can find now the factor of 12 and 24, which is 12. Okay? So, that is the second way or method on how we can find the GCF of certain group of numbers. And for the third method, we can actually use the long division method. So again, this is one method for producing the prime factorization of a natural number. So once again, let's have the example in finding the factor of 12 and 24. So the first thing you need to remember in the long division method is we need to find the greatest common factor of 12 and 24. So think of a number or a smallest prime number that the two given number are divisible. So 12 and 24 both divisible by 2. Okay, so 12 divided by 2 we have 6, and 24 divided by 2 we have 12. Now once again, use the same process. Think of the smallest prime number in which both the given numbers are divisible. So we have 6 and 12, and once again they are divisible by 2. So we have 3 and 6 for our answer. Now looking at 3 and 6, actually 6 is divisible by 2. However, 3 is not divisible by 2. So, think of a prime number na pareho sila ay divisible. So, we have 3. So, for the final, we have 1 and 2. So, now, 1 and 2 cannot be factored. So, we should stop on that part. So, just simply look at the left side. Okay, this part. So, you can see the prime numbers 2, 2, and 3. So, all we need to do is to find the product of these three numbers. And that is 2 times 2 times 3 is equal to 12. So, we have the GCF of 12 and 24, which is 12. Okay, so let us try to find the GCF of the following monomial, okay, or terms. We have here, or expression, we have here x squared, x cubed, and x raised to 5. So how do we get the GCF of those terms? So we have here x squared is actually the same as writing x times x. So you have 2x. Okay? Next, of course, for x cubed, we have 3x. So x times x times x. And for the last part, we have x raised to 5. Okay, so we have x times x times x times x times x. So now simply encircle or look at the part in which lahat sila ay meron. Okay? Kaya natin siya pinagpapantay-tantay. So, all of them have 2x's in common. So, that's why the GCF of x squared, x cubed, and x raised to 5 is x squared. Okay? So, after knowing what GCF is and how to find the GCF of numbers, let us now proceed on the polynomials. During your grade 7, you have actually prior knowledge about the polynomials. Okay, so once again, let us define polynomials. It is an algebraic expression that represents the sum of one or more terms containing whole number exponents on the variables. So looking at the examples, we have here 7xy squared z, 5x plus 3, 9x squared minus 4x plus 5, 10x plus 9y minus 3z. Can you still recall the types of polynomials in the given examples? What kind of polynomial are those? Let us see if your answer is correct. So we have here the types of polynomials. The first one is the monomial. In a term, mono means one. So meaning to say, monomial is a polynomial with one term. Okay? There's no operation in between the term. So we have, for example, we have 9a squared bc. We also have negative 7xy or simply 34. There's no operation in between and we only have one term. Remember, mono means one. Now, for the second type of polynomials, we have here the binomial. It's like a bicycle, okay? There are two wheels. So meaning to say bi means two. A polynomial with two terms. So as you can see on the slide, they are being separated by an operation, okay? In between. So we have here 10x cubed minus 5x squared. We have 20x squared y plus 4xy. And we also have negative 16x raised to 24 plus 3. Once again, when we're talking about binomial, they have a polynomial with two terms. Okay, so now we have here the trinomial. When we are referring to trinomial, okay? Let's have an example. In Kabanatuan, we have here the tricycle. Tricycle, there are three wheels. Okay, so meaning to say tri means three. So in terms of polynomials, trinomial means a polynomial with three terms. So we have, for example, they are being separated now into two operations. Okay, and 1, 2, 3, 1, 2, 3, 1, 2, 3. They are they're having three terms. So we have negative 8a squared plus 3a plus 4. We have 28m raised to 4 minus 3m squared minus 4m, or negative 11x raised to 7 minus 4x raised to 4 minus 3x squared. Okay, so we have the monomial, the binomial, and trinomial. However, if you can still recall, actually, if the terms are more than 3, there is what we call the multinomial, or as is polynomial. Okay, di ba? It's like poly means many, parang polygon, di ba? Many sides, something like that. So now let's have these examples. So first is to give the name for each polynomial and identify its terms and coefficients. Okay, so for example, we have here 10x squared y cubed. So what is the name of polynomial? That is a monomial because it only has one term. Next, what is the term? The terms is simply we have 10x squared y cubed. How about the coefficient? We have 10. Remember, we have the numerical coefficient. So now, let's have another example. We have here x squared minus 4. What is the name of this polynomial? Okay, this is a binomial. Okay, how about the terms? Okay, the terms is or are, we have x squared and negative 4. Since we're referring to binomial, there are two terms to be begin with. Okay, so aside from that, how about the coefficient? Since this is a binomial, you can make sure that the coefficient also 2. So we have 1 and negative 4. How do I get 1? Remember that when there is a variable and there's no any constant sa tabi niya, meaning to say, the constant in x squared is only 1. Okay, may 1 po doon. Invisible naman. Automatically yan. So now, I've been telling you the terms, algebraic terms or numerical coefficient. Again, during your grade 7, you have learned about this term. So let's have a short review. We have here the algebraic term, either a single number, a letter, or a product of several numbers or letters. So as you can see on the example for A and B. Now, for the numerical coefficient, we have here the number in an algebraic term. Just simply the number, okay? So, for letter A, we have 10, of course, and for letter B, since this is a binomial, we have 1 and negative 4. So, let's have another example. We have letter C. So, for letter C, we have 8x cubed minus 6x plus 2. What is the name of this polynomial? Okay, this is a trinomial. Once again, what are the terms? Let us see if you're correct. We have 8x cubed, negative 6x, and 2. Now, what are the coefficients? We are referring to numerical coefficients. Okay, so we have 8, negative 6, and 2. Okay, we have 2. Bakit ba 5 to? Ano siya? That is 2. Okay, that is only type 4, type 6. Okay, lastly, for letter B, we have x squared plus 8y squared minus x plus y. So, the name is, this is a polynomial, or you can actually use the multinomial. The terms are x squared, positive 8y squared, negative x and y, and our coefficient is, be careful once again, since this is a polynomial more than p, so we have the coefficient 1, 8, negative 1, and 1. Okay, so for the last part of our discussion, let us see if you can still recall how to write each polynomial in descending or ascending order. Okay, so look first at the letter A. We have here 5x raised to 5 plus 4x cubed plus 3x plus 10. So for descending order, we have here as is. Okay, while on ascending order, okay, when we're talking about descending, means from highest to lowest. Descending. Tagalog, bumababa siya, pababa siya. Okay? And while the ascending is that starting from the smallest up to the highest. So, the thing that you need to remember is to look at the exponent of your terms. Okay? So, for example, the exponent in 5x raised to 5 is 5. In 4x cubed is 3. For 3x, we have 1. So, meaning to say, it is descending because you're starting from the highest exponent down to the smallest exponent. So, same with ascending order. From smallest to the highest exponent. Okay? So, let us try for letter B. We have negative 2y minus 3y raised to 5 plus 7y cubed. Your answer for descending? Okay, for descending, looking at the exponent, we have negative 3y raised to 5 plus 7y raised to 3 minus 2y. And of course, for ascending order, we have negative 2y plus 7y cubed minus 3y raised to 5. So, again, thank you for listening for our discussion and hopefully you learned something today. Thank you and God